Hello everyone, my name is Dr. Aradhna Sahu, Associate Professor, Computer Science and Engineering Department from Shri Santosh Rungta Group of Institution, Rungta College of Engineering and Technology, Bhilai, Chhattisgarh. We are going to discuss the concept of extracting the hidden data from images using Python programming. This work is often referred to as stagnalysis. It is the process of revealing and retrieving concealed information from an image. This technique focuses on detecting, extracting and analyzing hidden data within multimedia files such as images. The goal is to determine whether an image contains concealed information, identify the presence of steganography and is possible extract the hidden data. The hidden data may have been embedded using various steganography techniques. All the types of explained already in previous video lecture, that is Introduction to Image Steganography. Let's take a short recap to embedding the data and extracting the data with the help of figure 1. In this figure, the image selected from hiding the information purpose is called the cover image. It is basically a normal image, or we can say original image, and the image obtained after steganography is called stego image. The image which has hidden or a secret data, the detection of the message within the cover image is done by the process of stagnalysis. It involves various methods, algorithms and tools designed to analyze and expose the cover data concealed within the cover medium. It involves various methods, algorithms and tools designed to analyze and expose the covered data concealed within the cover medium. Stagnalysis is one employed in the field like cybersecurities and digital forensic to detect potential threats or malicious activity involving hidden data. So let's discuss what are the following steps to perform extracting hidden data from images. The first step is image preparation. This process is start by acquiring the image suspected of containing hidden data. Convert the image to suitable format such as grayscale, RGB depending on the analysis techniques you plan to use. The second step is optional, that is noise removal. If the image has noise or artifacts, it's a good practice to perform noise reduction to enhance the analysis frequency. The third step is feature extraction. Extract the relevant features from the image that may indicate the presence of hidden data. These features could include statistical properties of pixel values, frequency domain coefficients, or other characteristics the steganography techniques may alter. Common features include histogram analysis, text analysis, and statistical movements. The fourth step is steganographic detection. It utilizes the statistical and machine learning algorithms to detect steganographic alteration in the image. These involves comparing the extracted features with those expected in a non-steganographic image. If you have information about the steganography technique used, you can attempt to extract the hidden data accordingly. These typically involves reversing the process used for embedding the data. The extraction method may include reversing bit manipulation, that is least significant bit inverse transform, DCT inverse, or using steganalysis tools tailored for specific steganography methods, data verification and encoding. After the extraction, verified the integrity of extracted data. It is essential to ensure that the extracted data is complete and not corrupted. If encryption or encoding was applied to the hidden data, apply the appropriate decryption or decoding techniques to obtain the original information. The last step is analysis and interpretation. Interpret the extracted data to understand its significance and purpose. This step may involve deciphering the message, check for the watermark information, and understanding the nature of concealed content. Now, we are going to perform this work using Python programming. It is being a versatile and widely used programming language, offers a range of tools and libraries for stack analysis. To use Python programming on our computer, there are several ways can set it up. Here are various methods. First, installing Python from python.org website. For this, you can visit the official Python website, that is python.org. Download the latest version of Python for your operating system, Windows, Linux or Mac operating system. Run the installer and follow the installation instruction. After the installation, you can open a terminal or a command prompt and type Python to start the Python interpreter. The Python IDE, Integrated Development Environment. There are many IDEs available for the Python development. Some popular ones include VS Code, a free open source code editor with excellent Python support; PyCharm, a popular Python specific IDE developed by JetBrains; IDLE, the default IDE that comes bundled with Python. It provides a basic information for writing and executing the Python code. The some online platforms are for Python is Google Colab, short for Google Collabority, is a cloud-based platform provided by Google that allows you to write and execute the Python code in web-based environment. It is typically popular among data scientists, researchers and developers for its ability to run Python code interactively, collaborate with others, and harness the power of Google's infrastructure for heavy computation tasks. To start Google Colab, it is a very simple process. Here are some steps and instruction for how to get started with Google Colab. First, we will open web browser and go to the Google Colab. If you are not already signed in to Google account, you will need to sign in or create a Google account because Google Colab requires a Google account to use. Once we are signed in, we will be taken to Google Colab loading page. To create a new Google Colab notebook, click on the New Notebook button. This action will open a new untitled notebook in a new browser tab. Now we will see a blank Colab notebook with code cells and text cells. So we can start working by typing Python code in code cells and adding the text explanation or markdown formatting in the text cells. To execute a code cell, click on the cell to select it and then either press the play button on the left side of the cell or use some keyboard shortcuts Shift plus Enter or Shift plus Return. The output of the code cell, if any, will be displayed below it. So we choose Google Colab platform to implement the code. Before we understand, let's take a short recap for encoding process, which is shown in figure 2. The complete description of this code is already discussed in previous video lecture, that is hiding data in images using Python. But now we understand the code for decoding process, which is shown in figure 3. This code is the remaining code after the encoding process. Now we will going towards extracting the data from images. The displayed code in figure 4 is to be a Python function for decoding hidden text from a steganographic image. Let's break down the code and learn each part. Define the function named decode text, which is shown in figure 4. Then reading the images that contains the hidden. So we type image equal to input method. This line prompts the user to enter the file name of steganographic image they want to decode, including the file extension. The input is stored in the variable name image_name. The next line of the code is for reading the image. Use image equal to cv2.imRead method. This line uses OpenCV library to read the image file specified by the user and stores it in the variable image. If we want to print some message like display the steganography image, we have to type print method with the comment steganography image is as follows. Then resize the actual images as per our requirement. We type resized image equal to cv2.resize image 500, 500. It then resizes the image to a size of 5 x 5 pixels and stores the resized image in the resizing variable using cv2_imshow method. Finally, it displays the resized steganographic image using the cv2_imshow function. Now, if we want to decode the hidden text, type text equal to show_data method. This line calls a function named showData method to decode the hidden text from the steganographic image. The decoded text is stored in the variable text. And finally, the function returned decoded text through the statement return text. The function returns the decoded text as its results. Next Python function is called showData, which is shown in figure 5, that is designed to extract hidden data from an image. So let's break down the code and explain each part. The showData method having one parameter image that as input and extracts the hidden data from it. Here bin_data equal to blank string initializes the empty string called bin data, where the binary representation of hidden data will be stored. The code uses nested loops using for loop to iterate through the pixels of the images. For values in image, it iterates through the rows of the image. For pixels in values, it iterates through the pixels within each row. Inside the nested loop, the code does the following of each pixel. The first line inside this nested loop, it calls a function message to bin function to convert the red, green and blue values of the pixels into binary format. Then it attracts the then it extracts the least significant bit LSB from each of the RGB value. For this, R index -1, G of -1 and B of -1, and appends it to the bin data string. This is where the hidden data is stored. After processing all the pixels, the bin data string contains the hidden data in binary form. The code then proceeds to split the bin data string into 8-bit chunks bytes and stores them into all byte list. Then it converts these binary bytes back into the characters using CHR integer bytes comma 2, effectively converting them from binary to their ASCII character representation. The code checks if the last 5 characters of the decoded data strings are hash. If this delimiter is found, it means the end of the hidden data has been reached and the code breaks out of the loop. Finally, the delimiter string with hash is removed from the decoded data string and extracted hidden message is returned. It is important to note that the success of these code depends on how the hidden data was originally encoded into the image steganography. The delimiter string hash is used to mark the end of the hidden message. So, the code expects the hidden message to be followed by delimiter. Now, the next function definition is message to bin, which is displayed in figure number 6, that is responsible for converting various types of data into their binary representation. Let's break down these function code and explain each part. This function message to bin takes one argument, message, and check if the input string is type string str. The code enters this block. It then uses a list comprehension to iterate over the each character I in the string. For each character, it computes its ASCII value using the ORD function. This converts that ASCII value to an 8-character binary representation using the format function with the format specifier 08B. The binary representation of individual characters are joined together into a single string using join, effectively forming the binary representation of the entire string. This binary string is returned. If the input message is of type bytes or a NumPy ND array, the code enters this block. If it uses a list comparison to iterate over each element I in the input. For each element, it converts its value to an 8-character binary representation using the format function with the format specifier 08B. The resulting list of binary string is returned. If the input message is of type integer int or a NumPy unsigned 8-bit integer np.uint8, the code enters this block. It directly converts the integer value to an 8-character binary representation using the format function with the format specifier 08B. The binary representation as a string is written as raised type error like input type not supported. If the input string is any other type not covered by the previous conditions, the code raises a type error with the message input type not supported. In the summary, the message to bin function is a versatile utility that can handle different types of input, strings, bytes, NP, and the array, integer, np.uint8 and convert them into binary representation. This method is useful for various tasks including steganography, where you may need to convert data into binary before embedding it in another medium. Finally, the steganography function initiating the steganography process based on the user's choice. We can see this code in the figure 7. Before running this code, we first revise the output of encoding process, which is already seen in previous video lecture, that is hiding the data in images. The screenshot of the implemented encoding process is shown in figure 8. It will ask the option for encoding or decoding, so we will choose option 1 to hide the data into images. After selecting the option 1, the details of original image will be appears on screen, which is shown in figure 9. The path of original image is content folder of Google Colab online platform, which is the current working directory. So we can see it on left pane and the name of file is test.jpg. The code prompts user for data which is to stagan or images, like enter the data to be encoded. It gives the text area where we can input the data for hiding into images, which is shown in figure 10, and then press the enter button for further processing. And then it will ask for the name and the path of encoded file. In Google Colab, as we know that our current working directory is content, so we just write only the name of file with extension, but before going to write the name, we first check the size of original file. It is now 6.73 K as shown in figure 11. Now enter the name of new encoded file in the text area, that is output.jpeg, and press enter key. After the some time, the output will store in the current working directory of Google Colab. Can also check the size after encoding process, and the file size is 14.42 K. The size is little bit increased due to some text has been injected on this output file, which is shown in figure number 12. After completing the encoding process, the code come back to the home screen, where we have two options, one for encoding and hiding the data, and two for decoding from extracting the data. The figure number 13 shows the output option for decoding. For decoding the output, we can opt option 2 and then press enter button. Then it is asking the name of Stago file, which is shown in figure 14. The name of file that conceals the hidden data is output.jpg file, which is shown in left pane on the figure 14. It will take few minutes to decode the output.jpg file, and the final secret data will appear on the bottom of the written code. There are many other options to build the code extracting the hidden data. Let's take another code for example which is using Stegno library file of Python programming language. Before going to decode the image, let's take a small review of encoding process. So, figure number 15 shows the encoding process. You can prefer the previous video lecture for detailed explanation of this encoding process. Now, we are going to decode the output of this encoding process. After running this, you will get a new image called output image.png that appears usually typical to the original image but contains the hidden message within its LSB as shown in figure 16, and its size is increased. Now it is 694.34K. So our challenge is extracting the hidden message. These can be extracted using appropriate steganography techniques. For this example, we have taken the Stegno library file. So the code of decoding process is shown in figure number 17. The decoding code uses the Stegno library to reveal a hidden message from a steganographic images. The steganography is the practice of hiding information within another medium, such as hiding the message within images. In this code, we are using LSB method for steganography, which involves hiding information in the least significant bit of the pixel value in the image. So here, step by step explanation of this code are: first, import all the library files. The first library is in this code are Stegno library. This library provides functions for steganography. PIL, Python Imaging Library. This library is used for working with the images. Then load the steganographic image. So, type steg_image equal to lsb.reveal method. This line loads the steganographic name output_image.png. Using the LSB method for relieving the hidden information, the lsb.reveal function is used to extract the hidden data from the image. Then extract the hidden data, we type hidden_message equal to stag_image.encode. This line extracts the hidden message from steganography image using the encode method of the stag image object. The encode method decodes the hidden data from LSB of the image pixel. Finally, we get the print hidden message using print method. This line print the extracted hidden message to console. The output of the decoding process of the Stegno image is shown in figure number 17, which is present below the decoding code in the simple print form. Note, it is important to ensure that the steganographic image output_image.png exists in the current working directory or provide the full path to the file image. If it is located in different directory, additionally this code resumes that the hidden message was originally encoded using the same LSB steganography method. If a different method was stored, so this code may not work correctly. Here I will discuss some practical implementations and considerations and also limitations of staganalysis using Python. The first, we will list out some practical implementations and considerations. The first is data preprocessing. This preprocessing is essential to ensure that the data you are analyzing is in right format and quality. For image stagnalysis, the common pre-processing steps include resizing, color space conversion and noise reduction. The second is feature extraction. It is a crucial step in stagnalysis. You will need to extract relevant features from the cover and stago images. These features might include statistical properties, frequency domain characteristics or other depending on the specific analysis method. The third is choice of algorithm. There are the various stagnalysis algorithm and techniques available. Consider which one is most appropriate for your use case. The popular approaches include use to machine learning, that is conventional neural network or statistical analysis, for example histogram analysis. Fourth point is training data. If you are using machine learning techniques, you will need a labeled data set for training. Collecting or curating a high quality data set is crucial to access of your stagnalysis model. The fifth point is performance matrix. Choose appropriate evaluation matrix to access the performance of stagnalysis system. The common matrices include accuracy, precision, recall, F1 score and ROC curves. The next is code libraries. Python has numerous libraries for image processing and matching learning such as OpenCV, scikit-learn and the TensorFlow. Utilize these libraries to streamline your stagnalysis implementation. Then testing and validation. Implementation cross-validation techniques to access the generalization ability of your stagnalysis model. Avoid overlifting by using validation sets. The last point is deployment and automation. Consider the practical deployments of your stagnalysis system where it's a batch processing of large data set or real-time detection in application. The automating the process can be beneficial. Now we are going to discuss the limitations of stagnalysis. The first limitation is detection rate. Stagnalysis is not always 100% accurate. The skilled stagnographers can create a stagno image that is difficult to detect using conventional method. The second is cover selection. The choice of cover media can impact the effectiveness of stagnalysis. Next, the third point is resource intensive. The complex stagnalysis algorithm, especially those involving machine learning, can be computationally expensive and may not be suitable for real-time applications. Next is adaptive stagnography. These techniques adapt to stagnalysis method, making it harder to detect hidden data. In the summary, the stagnalysis is a complex field that requires careful consideration of various factors when implementing it is Python. While it can be effective in detecting hidden information, it also faces challenges due to the adaptability stealthiness of the modern stagnography techniques. The researchers continuously work on improving stagnalysis method to keep up with evolving stagnography methods. The Python versatility and expensive libraries make it an ideal language for implementation stagnography techniques. These are Python libraries specifically designed for stagnography such as the Stagno library. This library simplifies the process of embedding and extracting the hidden data in images. So, it is most power tool for bit manipulation and binary data hiding, which are crucial for encoding and decoding the hidden information within images. When performing stagnalysis, it's important to have a good understanding of digital media formats and stagnography techniques that might be employed. These Python tools and library can assist it automatically the analysis process and extracting the relevant features for detection of hidden data. Depending on your specific stagnalysis needs, you may choose one or more of these tools to add in your analysis. Steganography techniques can vary widely, so you all need to adopt the code to match the specific techniques you are working with. Thank you. Looking forward to seeing you in the next video or whenever you need support. Have a great day. Goodbye.